Hello, my name is Dr. Simon Schmidt. I'm head of the Department of Hygrothermics at the Fraunhofer Institute for Building Physics, and I welcome you to the second video about the Lighthouse project in RAJKOT, where we discuss about the monolithic concrete construction using tunnel formwork as you are working in RAJKOT. This video is about heat and moisture transfer. Within this video, we will look deeper into the solar radiation, which comes to an opaque surface, and also to the temperature shift and attention in a construction or through a construction. I will discuss with you the basics of these two transport mechanisms, and in the end, we will implement them on the construction to RAJKOT, and we will see what changes are there if there is a dark or a light color on the outside, and what happens if we put an insulation on the outside or the inside of the construction. And with that, I would like to start with the first topic, as I mentioned, the radiation and temperature shift and attenuation. Starting with the solar radiation. If we look at the solar radiation on a surface, which is S, then we will see that there are different types of happenings that can occur. One is the absorption. Another one is the reflection. And sometimes there's also a transmission. As we are looking to an opaque construction, there is no transmission. So the transmission is not there in an opaque building component. There's just absorption and reflection. If we put that together in an equation, you will see that this equation looks like, as you can see here, the solar radiation is divided into the reflectance, into the absorptions, and into the transmissions. And this has to be the same, equal. As I said, for an opaque building, the reflection and the absorption is the only thing which will happen. And these two are dependent on the color of the surface, but also on the structure, the texture of the surface. As you can see it down here, where just the color is changed. The outside temperature, which is the black curve, is reduced if we use a black surface, which has a kind of amount of reflectance and absorptions, and is further reduced if we use a white surface. And please remember this. So if we change the surface color and the surface texture, this will occur, or this will lead to a difference in the absorptions and the reflectance of the solar radiation, and therefore also in the temperature on the surface, and as we see later on or on the next slide, also on the temperature on the inside. Because if we look at the temperature on the outside, we can say if the solar radiation S is coming to a surface and it's heating up and cooling down the surface, as there's day and night, we see that the construction itself changes this outside temperature as it is here in a sinus curve. It changes it to a slower sinus curve. And we also see that there's kind of a shift in time. This is due to the construction itself, because energy is not absorbed, but it's stored inside. And with that energy stored inside, it's going in and out, as we have seen in another video, which you can look at Chennai. The things that we are looking at now is the so-called temperature shift. So the maximum or the beginning of the temperature coming to the inside is shifted, sometimes by an hour, sometimes by more than an hour. And the second thing that we look at is the so-called temperature attenuation. So the maximum is reduced from the maximum outside temperature to a maximum to the inside temperature. And this is also dependent on the material itself, so dependent on the material we are using, and I can show you the influence on the next slide. What I have done here is I've calculated this temperature on the outside and inside. Here you can see the red curve on both graphs is the outside temperature, surface temperature, one here and one here. It's the uppermost temperature that we have. And on the left side, we look at a black surface. And on the right side, we look at the white surface. This is the difference between the left and the right side. And then the next thing I have done is I just increased the thickness of the wall by 5 centimeters, starting from 5 centimeters to 10 centimeters to 15 centimeters to 20 centimeters. And what we can see here is that we also have the temperature attenuation from the black surface, the outside temperature around about 47 degrees Celsius, and the inside by 20 centimeters around about 36 centimeters, so 10 Kelvin reduction. If we go to the white side, we see that the outside temperature is quite lower, so the outside temperature is around about 37 degrees, but also the inside temperature, so the attenuation is not as big, but we are on a lower level, is around about 32 degrees Celsius. And also we can see the maximum is shifted from the left to the right. On the right hand side, the shift is around about 2 hours, 1.5 hours, and on the right side where the white is, we can see also that shift, it's a little bit slower. So we can see on the one hand side the influence of the color, and on the other hand side with the different thickness the influence of the construction itself. We say the thermal mass that we have. This for the basics. Now go into the effects of the radiation and temperature shift and the possibilities to optimize that for RAJKOT. What I have done now is that I've put the construction that you are using, the concrete part of the construction, put a render on the left and the right side, so on the outside and on the inside, and then calculated the outside surface temperature and also the inside surface temperature. You can see the surface temperature displayed here, and you can see down here the temperature, which is just 1 day I've displayed out, as I simulate a whole year, which has 8,750 hours. This is 1 day in June. You will also see displayed down here on the right hand side the internal temperature over the whole year. What you see on the one hand side is that we have a temperature attenuation of round about 4.3 degrees Celsius from the maximum outside temperature to the maximum inside temperature. We also have a temperature shift of around about 1 hour, so that means that the maximum and the minimum from the outside to the inside is shifted to the right to later around about 1 hour. The next thing that we see in reality compared to what you have seen before is that if we go to the mean of the outside temperature, which is here around about 34 degrees Celsius, the inside temperature is a little bit higher. And in comparison, if we look at the whole year, the inside mean temperature, you can see that it's lower indeed. So it's lowered to 29.4 degrees Celsius. This is the basic construction. If we now do that and change the outside color of the render, for example, this is a dark one, and now we change that to a light one, we will see that there is a difference in the temperature attenuation. There is more or less similar temperature shift, but we will see also a change in the mean temperature for the indoor environment for that flat that we are looking at. And I would do that with going to the next slide. So you see, and I jump back and forth so you can see the change. If we change the color, the outside color, from dark normal surface to light surface, we see that the overall mean temperature of the outside temperature drops, and also the temperature for the inside for the whole year is also reduced. We also see, as we have seen before in the first graph I showed you, that the temperature is just below 1.9 degrees, but also the temperature shift is going down. If we go now further and say not just white color, but also putting an insulation on the outside, you will also see that we go a little bit further down with our internal temperature, mean temperature. We also go down a little bit with the temperature attenuation, and we have the same temperature shift. I switch to the next slide. There's just a minor temperature reduction that we have here, but you can see there is an influence. Maybe you have also looked at some of the videos which we produced for Chennai and have also looked at the changes between inside and outside insulation. You can think possibly of some different areas of inside and outside insulation and see whether there is a difference. So I have done that. I have put the outside insulation to the inside, and we will see what happens. If I do that, and I will jump back and forth on the slide so you can see the changes, you can see that there is just a minor change in the temperature attenuation, and you can also see there's almost nothing changing in that area of the 28.2 or 28.1 degrees Celsius in the average temperature that we have. Also, you see there's no change in that kind of temperature that we have down here. So you see there is no big change in terms of energy, in terms of having an inside or an outside insulation. The same is true for a lot of other constructions that we are looking at, but especially here it's for the energy perspective, there's not much change in it. But we will see in the other videos that you hopefully are looking that there are quite differences if we have an inside or an outside insulation, especially for the comfort, but also for the durability of the construction. But as we're here on the basics, and you have seen that the color on the outside has a huge impact, and also an insulation, whether it's on the inside or the outside, has a huge influence, I will summarize what we have learned today in the following slide. So what we see is that the absorption has a major influence on the outside surface of a temperature wall. Whether it's dark colored or it's light colored, there's a major difference in the outside temperature that we have. The outside surface temperature of a wall has also a major influence on the indoor surface temperature, and also then on the indoor temperature, as you have seen it before. So depending on the outside surface temperature and the material you're using, and also the insulation you are using, there's a difference in indoor temperature. By using bright colors, we also see that we can stabilize the indoor temperature. So having these in mind, we can then go to the next videos that you can look at. So there are other videos about the influence of these two aspects and even more aspects that we are looking at in the other videos you can look at in RAJKOT. And with that, I say thank you for listening today, and goodbye until the next video.